Hi. In this video, we're going to talk about an overview of composition of motion. Now, composition of motion is exactly like it sounds. It's taking different motions or transformations that we've talked about, and it's combining them or composing them, 2, 3, etc. So the ones that we're going to look at are, the first one is a glide reflection. Now, a glide reflection, when you hear it, sounds to me like a translation and then a reflection. I'm gliding and then reflecting. So a glide reflection is the composition of a translation and a reflection. The gliding motion is parallel to the line of reflection. So what that looks like, as an example, is if I have a triangle ABC and I translated it using this translation vector, I glide and then reflect over the line of reflection M. So as you can see, the glide reflection here as an example. The important thing to note is that this translation vector, or the movement at which the ABC is sliding or translating, has to be parallel to the line of reflection in order to be a true glide reflection. So let's look at taking two of these types of transformations and writing them as one rule. And so if I have a reflection over the x-axis and then a reflection over the y-axis, how can I write that as one rule? So what we know is if I have the coordinates x and y, when I reflect over the x-axis, the x coordinate stays the same and the y changes signs. So x would stay the same and the y would change signs. Well, then if I take this image and reflect it over the y-axis, the y coordinate stays the same and the x changes signs. And so there is my algebraic rule. Now looking at it, we should be able to see it and figure that is the same rule for if I rotate a figure about the origin 180 degrees. So this composition of motion can actually be written as a different type of isometry that we've talked about. So now let's talk about a consecutive reflection over parallel lines. Now, consecutive reflection over parallel lines, if I have the lines of reflection L and M, and then I have the pre-image ABC. If I reflect ABC over the first line to get A prime, B prime, C prime, and then I reflect it a second time to get A double prime, B double prime, C double prime, notice that the pre-image and the double prime image is the same. This is freehand drawing, so it doesn't look perfect like it would in class. But notice that it's the same figure. The A's are pointing outward, as I like, and then the BC are kind of on the tail end. Notice this looks just like a translation, and it is. A consecutive reflection over two parallel lines essentially is a translation twice the distance of the distance between the two lines. So if you think about it, if I go a distance, what we know about reflections, a distance d from the pre-image to the line of reflection, I have to travel a distance d. Again, I go, and if I go the same distance d, I'm reflecting over the next line with the distance d. And so essentially what's happening is I'm translating twice the distance of the distance between these two lines of reflections. And so to give you more specifics, if this was 4 centimeters, I would have to travel 2 centimeters and then 2 centimeters again to get this image. So, or 4 and 4, which would be a total translation of 8 centimeters. The last one we're going to look at is consecutive reflections over intersecting lines. So look at the example that I have where L and M are perpendicular to each other. ABC is reflected over L and then reflected again over M. Well, what we did is when we wrote these two reflections in one rule in a previous example, no, it's the same as rotating it 180 degrees. So this kind of double reflection over intersecting lines rotates twice the measure of the intersecting angle. In this case, the angle between the angles of L and M would be 90 degrees, so now I'm rotating 180. Thanks for watching.